Okay, we want to use substitution when one of the equations that they gave us is an x equals or a y equals equation. So graphing, the easiest way to use graphing is if they're both y equals equations, right? Y equals mx plus b, they're easy for us. But let's say one of them is in standard and another one is given to us and it has that x equals or y equals, it's going to be easy for us just to plug in. And I'll show you exactly what that means. So for example, number one is a y equals versus the second equation is in standard. So what we do is we take the fact that this is a y equals and we're going to substitute it in there. So this y is going to go for this y. So I take my bottom equation, 2x plus 3, and now I have to substitute what y does equal, which is 6x. Now I'm solving just like I would solve a regular equation. 3 times 6x is a positive 18x. 2x plus 18x, I just combine like terms. That gives me 20x. And then I divide both sides by 20. X equals negative 1. Now remember, solutions to systems of inequalities are ordered pairs. So that's just my value for x. So now I take the value for x and I can plug into either equation. I personally would go for the easier equation, which is up here. So y equals 6x. I just rewrote it. If I know x equals negative 1, now I can plug in x equals negative 1 for this x. So y equals 6 times negative 1, which is negative 6. So now my solution is that ordered pair. So I have to put it together, and the solution is negative 1, negative 6. Here's the next one. I look for them, and sure enough, here is an x equals equation. So this is an x equals, so I'm going to plug it in for this x right here. So I take the fact that x equals y minus 7 and I plug it in here. So y minus 7 plus 8y equals 2. I don't really need those parentheses, so I can just drop them. Make sure you put that this is a 1y. So 1y plus 8y is 9y. Add 7 to both sides and divide by 9. So y is equal to 1. Remember, that's not my solution. That's just what y is equal to. So now I take the fact that y equals 1, and I'm going to substitute into this entire equation up here. So I rewrite it. X equals y minus 7, and I plug in that y is negative 1. Oh, nope, sorry, not negative 1, positive 1. So 1 minus 7 is negative 6. So my solution is the ordered pair x, y. So my x is negative 6, my y is 1. Next one. Both of these, now this is where people get freaked out. Both of these are y equals. So if I told you to choose any method, these are already in slope-intercept form, I would personally graph them. However, if I tell you have to use by substitution, which in this case I am, they're both y equals. So what we know is if they're both y equals, or if they were both x equals, we know that y equals y. Therefore, we just set them equal to each other. So 2x minus 2 equals x plus 2. And now we solve. I subtract x, and I add 2. So x equals 4. So that's my x value. Now I plug in, I'm just going to take the top equation. So y equals 2x minus 2, and I plug in the fact that I know x is 4. So 2 minus 8, or 2 times 4 is 8, and 8 minus 2 is 6. So my solution is the point xy, so 4, 6. Next one. All right. So I'm looking for an x equals or a y equals. I don't see either. So then I start to look, and I'm trying to find a variable that does not have a coefficient. Remember, a coefficient is the number that touches the variable. So this is the only one that does not have a coefficient. The reason is because it's one less step for me to convert. So I'm going to solve for x. So I'm going to go ahead and take x plus 4y equals 8 to the side. And I'm going to solve for x by just subtracting 4y to both sides. So now x equals negative 4y plus 8, okay? I'm going to take this x equals, and I'm going to plug it in for here. If I were you, I would get rid of this equation so you're not tempted to reuse it, okay? So now I'm going to plug in that x right there. So 2 times, this is what my x equals, negative 4y plus 8. Now I write everything else. Minus 5y equals 29. Now I have to distribute. 2 times negative 4y is negative 8y. 2 times a positive 8 is a positive 16. Drop everything else down. Combine like terms. Negative 8y minus 5y is a negative 13y. Subtract 16. And divide by negative 13. So my y value is equal to negative 1. It's up to you where you want to plug it in. I would just go ahead and plug it in right here. So x equals negative 4 times supposedly, or not supposedly, we found out my y is negative 1, so I plug in negative 1. Negative 4 times negative 1 is 4, and 4 plus 8 is 12. So that's what my x equals. So now my solution is the point xy, so 12, negative 1. Okay, 2 more examples. All right, lucky for us, they gave us a y equals equation. So y equals, I'm going to plug it in here. So I take this and I go there. So 2x minus, my y value is 2x plus 6, and then equals 2. Now I have to distribute this negative 1. So let's just rewrite 2x. Negative 1 times 2x is negative 2x. Negative 1 times 6 is negative 6. Combine like terms. 2x minus 2x is 0, so they cancel, leaving me with negative 6 equals 2. Negative 6 never equals 2. Therefore, my solution is no solution. That's actually nice, right? One less step. We don't have to anything to plug in. And last one. All right, so we look at both of them. Neither one of them have an x equals or a y equals, but this x does not have a coefficient, so I'm going to take it down here. All I have to do is add 2y to both sides, and x equals 2y plus 3. Once again, I'm going to get rid of that equation so I'm not tempted to reuse it. Okay, so now that I have a 2x, not a 2x, an x equals, I'm going to plug it in for right here. So 4 times my x value is 2x plus 3, or 2y plus 3, minus 8y equals 12. Distribute. 4 times 2y is 8y. 4 times 3 is a positive 12. Combine like terms. 8y minus 8y is 0, so those cancel, leaving me with 12 equals 12. 12 always equals 12, so that checks out. Therefore, my solution is infinitely many solutions. And you can, once again, you can write that out, or you can just write the infinity sign for me, okay? Here are your practice problems. You must use the substitution method on all 6. If you want to check your answers using graphing, you're more than welcome to, but you have to use substitution.